Alright, our last bit of notes for this unit is net ionic equations. Net ionic equations are equations that are written for double replacement reactions that remove the spectator ions. So remember when we talked about double replacement reactions, we talked about the formation of a precipitate. The spectator ion is any ion that does not take place in the formation of that solid. So we oftentimes associate this with single replacement reactions as well, but we will not talk about that in regular chemistry. So there are a couple different steps. The first is to determine the solubility of each reactant and product. Really, more importantly, we're going to look at that product that precipitates out. Once I've identified what's going to precipitate out, it becomes very easy to write a net ionic equation for that reaction. Ionize any and all soluble compounds, cancel spectator ions, and then rewrite and balance the equation. So let's practice. Iron chloride reacts with ammonium hydroxide. So remember that iron is Fe. This number in parentheses gives me its charge. So that's going to be 3. Chlorine has a -1 charge. So when those crisscross, they form FeCl3. Plus ammonium hydroxide. Ammonium is one of the only positive polyatomic ions, NH4+. It's going to bond with hydroxide, OH negative. When those crisscross, they form NH4OH. So remember with a double replacement reaction, I have positive ions and negative ions, and they crisscross. So iron's going to bond with hydroxide, ammonium's going to bond with chlorine. So we'll start with ammonium chloride, NH4Cl. They both have a 1 charge, so it cancels, plus FeOH3. Iron has a 3 charge, hydroxide has a -1 charge. When those crisscross, they form FeOH, and the 3 has to distribute to the OH. Before we balance, let's check our solubility rules to determine what's going to form our solid. So all chlorides, bromides, and iodides, except silver, lead, or mercury, are soluble. That's in the first column, second bullet. Now let's find hydroxides. All hydroxides except group 1, strontium, barium, and ammonium are insoluble, which means that this iron hydroxide is going to be my solid, or my precipitate. That's the first step in a net ionic equation. Next step is to ionize everything except for what's insoluble. So I'm going to go through and I'm going to write all of these compounds just as ions. So Fe becomes Fe plus 3. Cl would be written as Cl negative. So see what I'm doing? I'm just breaking apart the compounds and writing them based on the ions that they form. And we are going to assume that everything, with the exception of FeOH3, is soluble. So I've ionized all of my pieces except for my insoluble solid. Okay? Now, what two elements or compounds are taking place in the formation of that solid? Iron and hydroxide. So I'm going to cancel anything that's not iron or hydroxide. Cl, ammonium, ammonium, Cl. I've canceled my spectator ions. Then I rewrite the equation. So I only bring down what's left. And then technically we should balance this, but we're not going to worry so much about balancing. I just want you to get the over idea of writing a net ionic equation. All right, let's work one more of these. Potassium chloride and sodium nitrate. That should say potassium. KCl, potassium plus 1, Cl negative 1, and sodium nitrate, Na plus 1, NO3 negative 1. Okay, remember, positives and negatives. Sodium's going to steal chlorine, potassium's going to steal nitrate. So when I rewrite that, it becomes NaCl plus K NO3. Before I balance or worry about spectators, I need to figure out what forms a solid. Chlorides are listed under the first column of soluble. All chlorides, bromides, and iodides except silver, lead, or mercury. Well, so sodium chloride is soluble. Let's find nitrates. All nitrates, acetates, and ammonium are soluble. So neither sodium chloride or potassium nitrate form a solid, which means that there is no reaction. I cannot write a net ionic equation for that reaction. All right, we can work one more, and then I think we will be done. Just want to make sure. Let's work this one, but let's change magnesium to calcium. All right, so calcium chloride, Cl plus 2, and Ca plus 2 and Cl negative 1 is going to form CaCl2 plus aluminum. Remember, aluminum has a 3 charge, so when I crisscross that with sulfate, which has a negative 2 charge, I form SO4, Al2, SO4, 3. Go in and put my positives and negatives, positive, negative, positive, negative, and then crisscross. Calcium and sulfate, aluminum and chlorine. And that's going to form Al Cl3, right? Aluminum has a plus 3, calcium has a negative 1, so that forms AlCl3. Plus, now I need to bond calcium and sulfate. Calcium has a plus 1 charge and sulfate has a negative 2 charge. So that's actually going to form CaSO4. Drop the charges because they cancel. Now let's go read our rules. Chlorides are listed under the soluble, second bullet. All chlorides except silver, lead, or mercury. Well, aluminum is not silver, lead, or mercury, so it's soluble. Now let's find sulfates. All sulfates except calcium, strontium, barium, mercury, lead, and silver are soluble. Well, calcium is the exception. So calcium sulfate is going to be our solid. The next step in writing a net ionic equation is to ionize everything that's soluble. So that's everything except calcium sulfate. Ca2 plus Cl negative 1 plus Al 3 plus SO4 negative 2. Al 3 plus Cl negative plus calcium sulfate. All right. Now we need to cancel our spectators. Spectators are anything that are not participating in the formation of that solid. So calcium and sulfate are my only two pieces that will not be canceled. Chlorine's canceled, aluminum's canceled, aluminum's canceled, chlorine's canceled. Now I can rewrite my equation. Ca2 plus SO4 negative 2 yields CaSO4. This is what I have to see. The rest of this you can do on your own to help you get to that last net ionic equation. You do not have to show all of that work, but until you have a fairly strong grasp of this material, it will help you to work it out step by step.